All right, so again, to go and do a problem like this, what I would do is I would just apply what's in the parentheses first, and I would just write everything in vector form. So I have 1/2 times parentheses, 3 times this in component form, which would be 2, -1, plus vector form 1, 2. Right? Now I can apply my scalar. So I have 1/2 times 6, -3, plus 1, 2. Now I can combine these, right? When you add, you just add the first coordinates and second coordinates. So I have 1/2 times, that becomes 7, and this becomes -1. Now I can apply the 1/2 here. So I have 1/2 is 7/2, comma, -1/2. Okay? So now how are we going to go ahead and graph that? Well, 7/2 is pretty much the same thing as the decimal 3.5. So I go over 1, 2, 3, 4, and it's going to go down 1/2. So I go over 1, 2, 3.5, down 1/2. It's about right there. Okay? Now let's go and look at what exactly does the vector look like. All right? So in this case, our vector, what we're going to want to do is if I distributed this, what I'm trying to find is the addition of 3/2 u plus 1/2 w. Right? So that's what I'm trying to find the addition of, is those two vectors. Right? Because remember, when I want to show this geometrically, I'm trying to show it as the addition of two vectors. So the two vectors I want to have the addition of is 3/2 u plus 1/2 y. So 3/2 u, you can say here's your u, is going to be 3/2 u. So that's going to be 6. That's going to be 3, -3/2, plus 1/2 w. So here's our w. 1/2 of that is going to be 1/2 1. Would everybody agree with me on what I did? I just multiplied each one of those by scalars, because again, geometrically, you want to show it as two smaller vectors adding up to give you your larger one. So let's go and graph 3/2 u. No. So to graph 3/2 u, that's going to be over 3, 1, 2, 3, down 1.5, 1.5. That's what we call 3/2 u. Then, to graph 1/2 w, we'll do this in green. That's over 1/2, up 1. Okay? So now you guys can see how the addition of these two vectors provides you our resultant vector, which is 3/2 u plus 1/2 w. Okay? And there you go. Isn't that amazing?